There are actually some good principles out there for when you're thinking about how to structure your application. And we're going to go through some of those and walk through the meaning of those principles. And then lastly, I'm going to discuss how to use components in NIWeek and give a little bit of a peek into some of the design insight that we had and how we came up with how we present these concepts to you all. So just a warning, we're going to go deep into some software engineering principles here. This isn't all just code, it's a lot of concepts. But this is the CPAD track, so I figured everyone would be cool with that. But I just wanted to warn everybody. So first off, what is a component? And you notice I have two, slides are getting cut off. No, I have two images here. When I think about components, I think about two things. I think about cups and lollipops. And you may think that's a really strange set of things to bring up when talking about software, but trust me, it makes sense, and we'll get to that in a minute. So what are components? Well, first off, components organize your code. In NIWeek, this is the primary way you organize your code, is with these component objects that we'll talk about more specifically later. They also are the unit of deployment, right? When you think about, here I have this chunk of code, I want to give it to the people down the hall, I want to put it on the tool store, or I want to distribute it on the lava forums, or wherever it may be, these are sort of the main chunk of code that can be deployed together, that makes sense to go out the door together. They also do two other things in terms of how they can structure your application. And this is where the cups and lollipops come in. So first off, they export VIs within them, right? So components actually provide some set of functionality. If a component was just a collection of code that didn't do anything, then it's just a black box with no buttons. That's not very useful. So they export code. They allow you to basically provide functionality to your consumers. And these are, obviously, the lollipops. They also depend on other components. And this is where the cups come in, right? So you actually may have dependencies in other components that have to be fulfilled by something else. And you don't really actually usually care what that is. It is that, in NIWeek, it has a specific signature pane, or a specific con pane, and it has some functionality that you were expecting. And you put all this together, and you create applications, where you have these components at the bottom, which are providing some base level functionality. And as you go up, you have less and less dependence and maybe more and more dependencies. And at the top, you have your UI, your application, your top level, the thing that your users actually interact with, the people using the application. You may be thinking to yourself, yeah, but why do I need to use components? I mean, that's cool and all, but that's way too much stuff. That's way too much computer science. That's way too much software engineering. I just want to do this thing. And sometimes, actually, you're right. If you're just trying to take a measurement, you don't necessarily need to have components, right? If I just want to voltage off some random board, that's fine. But if you're actually thinking about applications and larger scale software, or thinking about distributable libraries, the distributable chunks of code that you want to get out there, components are really the way to go. So I like to, if you've ever seen my other presentation on interfaces or traits, I love to create spectrums of things. And so this time I created my spectrum of code organization. So on the far left, we have loose files. And this is actually perfectly appropriate in a lot of situations. Like I said, you just want a VI, take a measurement, no big deal. All the files are in a spot. You maybe have some naming conventions that make sense to you. You distribute using source files. Hey, here's this VI, go do this, it works. Great. And a lot of times, that's good enough. As we move a little bit more to the right, maybe we're using multiple folders, right? So each folder contains things that make sense to go together, or some set of functionality. Basically, folders have some meaning to you. They don't have meaning to the IDE, however, to LabVIEW, to the thing you're using to actually build your code. And that's the key difference. And so you may put associated files of some type in the folders together, have some scheme, whatever, but you're basically just using the file system with no knowledge from the IDE down of how you're doing that. And lastly, we get to components. And this is where you're putting related code in these components, right? And the key thing here, like I said before, is IDE knows about these components. It has meaning to LabVIEW. It knows when this code's together that there's something I can do with that. I can build that together. I can collect it together. I can reference it in certain ways. The code is now distributable and consumable, right? So like I said, those exports, those lollipops. Now you're saying, hey, it has these key points that I'm providing to other users. And it makes the organization more scalable, right? If you start to get into the thousands of VIs, dealing with folders on your own is really painful. LabVIEW knows what a component is. LabVIEW knows what a component is. As you move files around, we automatically update the references for you. We automatically deal with all the linking. We know about these things. And so now your organizational concept not only has meaning to you, but has meaning to the IDE. It makes your application that easy to build, that more easy to distribute, and that much easier to scale. So, the first half of the talk is best practices. So we're going to go into some of these software engineering concepts that talk about good component design. And hopefully, we're all this happy afterwards. So good component design. There's really two concepts when we talk about component design we need to refer to. One of them is cohesion. And what is cohesion? Cohesion is what goes into a component. And dually, what does not go into a component together. Right? So which we put in and which we keep away. The second one is coupling. And coupling is more about how components talk to each other, how components interact with each other, and what are the right kind of interfaces we need to have. That's a really loaded word. What are the right kind of communication points we need to have between components that make your application well structured and your application easy to maintain. So there's two sets of principles. One set of principles for cohesion, one set for coupling. And I'm taking all this from this book, Clean Architecture by Robert C. Martin or Uncle Bob. If you've gone to a lot of these the sessions in this track, you've talked about solid principles. This also comes from this book. Uncle Bob loves himself some Uncle Bob, don't get me wrong, and there's a lot of that in the book, but when I read through it, I was actually very impressed. And I've heard about these principles for a long time. The ones about components, when I was looking, working on this talk, and I read through this part of the book, and I was like, he does a really good job of distilling in a relatively short number of pages what are the key things you need to think about when you're writing a good application. And he even has metrics and all kinds of stuff. I'm not going to get into all the details of the metrics, but I was actually very impressed by this and built the talk around it. So one of the themes of this talk is go read this book, specifically the components part, and I'm just giving you sort of a quick drive-by, 10,000-foot view of his principles. So on the cohesion side, there's reuse release equivalence, common closure, and common reuse. On the coupling side, there's acyclic dependency principle, stable dependency principle, and the stable abstraction principle. And we're going to go into detail about all 6 of these. So cohesion principles. The first one is the reuse release equivalence. And this one I actually always used to get backwards, and now I realize, no, it's the way it is very purposeful. And this is saying that the granule of reuse is the granule of release. And what it says is if I have 3 VIs and I'm always releasing to the customer at the same time because they need all of them, those things should go in a component together, right? If I have to give someone those things all the time together and they have to be given away together, they should be packaged together, right? They should be collected together into a component. There we go. The second principle, and at any point if you have a question, interrupt me. This is meant to be interactive. Is common closure. And so this is saying that things that change at the same time should be in the same component, and things that change at different times should be at different components. So for example, if we have orange and purple here that I change, say, every 6 months, and I have green and yellow, which I change the other 6-month period for whatever reason, business rules or regulation purposes or whatever. But if I'm changing these at similar times, then orange and purple should go in one component, and green and yellow should go in the second component. Right? If they change at the same time, that's a good reason to put them together in a component. If they change at different times, it's a good reason to keep them apart. So that one's pretty straightforward. Common reuse. This one's kind of interesting because it's saying basically what should not be in the same component. And one of these is that if, let's say, orange depends on purple and green, right? But yellow is just kind of off by itself. I mean, it's interesting, but it doesn't really have, it's not in the dependency tree of these other ones. Well, if the user wants to use orange, there's no reason to make them depend on yellow too. They don't need it. Orange doesn't need it, they don't need it. That shouldn't be in the same component. So I shouldn't just shove stuff in the component just because. I should shove stuff in a component because the person who is using the component needs all the things in that component. So, okay. So let's get to coupling. And coupling talks about how things interact. That's why I picked the kittens. I also just like cats. So the first one is acyclic dependencies, and this says that allow no cycles in the component dependency graph. So what is a cycle? A cycle is simply when one component depends on the other component. This is bad, don't do it. One of the nice things is we actually enforce this in LabVIEW. We will not let you build two components that depend on each other. Or have multiple components that somehow create a cycle. So cycle, when it's just one-to-one, that's easy. But sometimes you have some pretty intricate graphs of dependency. And if you can go pick one and get back to that one along that graph, you have a cycle. And we actually detect that, and we don't let you do it. So this is one of these principles that we actually enforce in the ID, which I'm pretty excited about. And yeah, don't do this either, right? Like, it doesn't matter how complex your cycle is. Actually, the more complex your cycles are, the more you shouldn't be doing them. And the reason you don't want to do this is because it creates these, if I'm working on code and say you're working on code, and you change it, the next day I come in and I've changed it, and we're depending on each other, like, we're just stomping on each other all the time. And this gets worse and worse as the organization gets larger, as there's more people working on the code, as your applications get more complex. So enforcing rules like this helps you use components to actually scale to create bigger applications. So how do you actually fix the cycle? This is sort of a common thing. There's a lot of tools to do this. There's a good section in the book about ways to fix it. But the one that I think is pretty common is you identify the chunk of code that was supposed to say component 3. It's currently behind the box. That component 3 actually depends on this component in the upper right? So this orange chunk represents the piece of that second component that actually is dependent on by the third component. Well, you can actually pull that code out, and now both of these components depend on this fourth one. And now there's no cycle, right? So one of the things to keep in mind here, and as I go through the exercise, I think it'll become clear, is that component architecture is never static, right? As your needs change from your customers, as your applications change, as you add features, your component layout may need to change too. And that's okay, because you always should be thinking, hey, does my architecture meet these principles in a good way? If it doesn't, then it's time to actually go and change what you put in the component. And that's okay, like that's refactoring. That's one of the key principles of, like, if you read this, a lot of books on software engineering, you should be able to embrace refactoring, and component design is no different. So the next two principles are a little more interesting. The first one is stable dependencies. And it says to depend in the direction of stability. And he has an interesting definition of stability, right? Stability to him is basically not how often something changes, but how painful it is for something to change. So if you have a lot of dependence, that pushes you to be more stable. Because when I change, I'm going to impact a lot of other components, and that hurts. So I don't want to change, right? And if I have more dependencies, that makes me less stable, because something can come in underneath me and change, and now I have to change. I have to update my component or rebuild or something like that. So the more, basically there's a ratio of dependence to dependencies, which is some metric of stability. If I remove my dependencies and I just have dependence, I've made this component more stable by his definition. And he has another definition, which is what I think most of us generally think of as stability. But he actually refers to that as volatility. And this is actually how often does the code change? And these two things are separate. And so to use the principles, you kind of have to keep that in mind. So to get back to the stable dependencies principle, up at the top, we have a component that only has dependencies. No dependence. So that's extremely unstable, right? So that's good. So that has a very low dependency metric. And just in NXG, we kind of enforce that as well. Your top level component in NXG is actually called an application component. That application cannot export things. We restrict that. So we sort of get you started in the right way and saying your top level component has to be very unstable by its definition. That sets you up for a nice architecture moving forward. So as we look at this example, right, these components in the middle do both. They have dependencies and dependence. So as we've gone down, obviously those are more stable than the top one, and so on and so forth. Where we get down to the bottom, and there's no dependencies, and it says only dependence, this makes those very stable by his definition. The rule to take out of this is all, okay, great, I can draw these things, whatever. The rule to take out of this is that when you start to depend on something, that thing better be more stable than you. And that's the way I think about it. Anytime I have a component and I'm going to make it depend on another component, I better hope that that component I'm depending on is more stable than I am. Or you're setting yourself up for a world of pain, basically. And that's kind of the, if I had to pull a sort of day-to-day philosophy out of it, that's the way I think about it. The last one is stable abstractions. And this is a component should be as stable, as abstract as it is stable. So here again, we have a very stable component, only exports, no dependencies. And what he's saying there is that basically, what you're actually exporting better not be very concrete and set in stone. It better be very abstract. And then currently in LabVIEW, what that means is like abstract classes, right? That has a bunch of definitions and methods, no concrete implementations. This makes a lot of sense in some of the other languages that have things like interfaces. As interfaces come along in LabVIEW, this will, I think, be easier to fulfill this principle. But there's an exception here, which is that it's okay to be concrete if you're non-volatile. So take the string library in a lot of languages. It's extremely concrete. It tells you how to make strings and put them together and count them and all that kind of stuff. But it never really changes. And so everyone depends on string library. But it never changes, so that's cool. So it's extremely stable. It's extremely non-volatile. That's all right. That allows you to have a nice, clean bottom layer. Okay, enough theory, enough, me wishing I was a professor. Let's move on to actually using this in the product. So, LabVIEW actually has two types of components, as I alluded to earlier. There are applications and libraries. Applications are top level, as I said, no exports, only dependencies. So we're sort of enforcing that depend in the direction of stability rule. And they build into things like EXEs, bit files on the FPGA, RT executables, web apps. These are the things that define what the user is going to actually see, what the final customer is going to do, what your application is going to actually show to the user. The other one is libraries. Libraries can have exports and dependencies. And they build into something we call GLLs on the desktop. And GLLs are basically the binary, the compiled binary result of taking a library on the desktop on the computer and actually compiling it, going from the source to the binary result. And this is the packed project library replacement. I'm going to get a little more detail on that in a second. On other targets, it actually gets absorbed. So for example, in FPGA, you just end up with one bit file. It doesn't make sense to have multiple chunks. Same thing with RT and web for the moment. And I want to reiterate the point that these components are your main organizational tool in LabVIEW NXG. Not folders, not anything else. Components are really how we design the whole experience around, and we think provide the most power and the most scalability, and basically help you design your applications the best. So when is all of this stuff available? Well, components are actually here now. LabVIEW NXG 2.1 and after has components. Now, like I said, this should be your main organizational tool if you're starting in NXG. We have applications and libraries there. The big thing that's changing are these GLLs. Like I said, this is the built artifact of a desktop component. And these replace packed project libraries for PPLs. So no longer do you have a situation where you have this other project that has a PPL, and you have to reference that in your main project. You just have a library. And on the desktop, it builds into a binary PPL. So your binary application is also componentized. But on other targets, it does the right thing. So there is no notion of a packed project library or a binary library in the editor. In the editor, you just have applications and libraries, and that's it. This is actually coming in LabVIEW NXG 4.0. So if anybody came to the test lab yesterday, we demoed this, we had a script for this, we have one of the exercises to go through that work. GLLs are also going to be used for plugins. We actually have the plugin architectures. But that's further out, and I'm not going to really get into the details of that because we're still figuring some of that stuff out. I'm very excited about GLLs coming out. I think really the beauty of what we're trying to do with libraries and applications in NXG will sort of be able to be seen by you all when we get this out the door in 4.0.
Here?
Yes, sir.
Quick question about that. So the GLLs, those are compiled into a GLL file, and then we bring them into our project. And does the exported VIs from that GLL how are those presented to the user?
Yes, so the question is basically, if I have a GLL and I bring it into my project, how do I see that as the user? So in our first release, actually, you won't really be able to drag those in. The GLLs will only show up as kind of a, when you build an application, the other libraries you have in your project will build as GLLs. Eventually, obviously, that will also be the unit of reuse and consumption. And we need to go through some design exercises on that. But the general expectation is you pull a GLL in the editor, you'll see it in the palette. So we'll put it in the palette in a special place. Hey, I just dropped this thing in, or I installed an add-on that had a GLL in it, or whatever. It'll show up somewhere in the palette so you can just access it like any other set functionality. We are just to say, we're taking a very staged approach with this. So I mean, so Michael is my managerial counterpart here for our team. We have really pushed hard to figure out what is the slimmest slice of this stuff we could get out the door earliest, so people could start playing with it, people could start seeing it, using it, getting us real feedback. And we're going to try to every release get out more and more functionality. But we're pushing very hard to do a very iterative release of the value on this feature, or this set of features, I should say. So some design insight. So the first one, that's very different from the current product, is that the component layout matches the file system layout and vice versa. You may have read my post on the forums about this. You may have seen the anger that happened after I posted on the forums about this, and hopefully I have my explanations did a good job. But we really do believe in this. And having used NXG a lot now, I can't think of it another way. This is a well accepted actually in many other languages. Like Java's been doing this for 20-something years, right? And we feel that it actually provides a level of organization and scalability that loose files just can't provide. Because again, as I was saying earlier, NXG knows about these components. They also know how stuff is laid out on disk. And so we do this stuff we do a lot of the refactoring for you. One of the big questions is, you're going to make me make my disk layout match my application? And the question is, no, not really. We're going to do that for you. So if you have something in a component, like I said, you should always do refactoring, and you move it from one component to the next, we move it. We update all the references. We make sure everything still works. If we can't do that well, we actually tell you, sorry, there's some name collision or something, we weren't able to do that right. We actually put a lot of effort into getting these refactorings right, and like I said, I think you all are going to be really happy with it. Yes?
So one thing that gives me a headache when I move things within LabVIEW currently is if I'm using source code.
SVN, specifically.
Yeah, so how are you, because I assume you thought of that,
yeah.
and so how are you addressing that in this thing? Oh, if
right.
I move one here, there.
So, sorry, my voice is starting to go. That is a problem, and especially with I think some of the more classic SCC, like source code control systems, that is an issue. That's an issue anytime you move anything on disk, the history disappears, unfortunately. We are trying to design this looking forward. I think as you move to more of the distributed systems like Git, Mercurial, stuff like that, they do a much better job of handling history on move. And so you're right, that is an explicit trade-off we made. I think as we've seen in the past couple of years a pretty surprisingly almost drastic adoption moving over to the Git and Mercurial, stuff like that. So I think from a further on point of view, this won't be as much of an issue. But I agree right now, this can be very painful. And so, especially if you kind of do some mass move, it's just a real mess. But like I said, I think we are seeing more and more people move towards Git, which handles that much better, or other Git-like type systems. So it's not we don't have a great solution for it, but I think we're going in the right direction. We're kind of keeping up with industry trends on that front.
Do you know if there are plans to work on source control integrations that might also assist with that?
Nate is not here. Anyone else here? What?
But I don't know the answer to it.
Yeah.
We do recognize that source code control is important and a necessary part of your workflow. So,
Yeah.
I just don't have a question.
Probably, but you can't say anything, you don't know.
Well, yeah, I
It's not
mean,
in the weeds of
yeah.
that.
Right. We did put some energy in that. I'm not sure exactly where that falls for future business stuff. So the second thing we've introduced is namespacing. And this one is also a very common concept in a lot of programming languages, right? And it gives you kind of a different organizational tool than components. Components are more about physical organization, distributable organization, reuse, things of that nature. Namespacing is more of a logical organization. Say maybe your company name, right? All the things that your company provides need to be in the same, some similar namespacing structure. And so namespace actually gives you a way to kind of have an overlay of logical organization regardless of your physical structure. And namespacing works with both classes and components. So as you have classes, components, and the mix of those things, the namespacing can interact across all of them and give you sort of a nice logical organization that really transcends the way where things are laid out on the disk. Okay. So I promised some actual building, and then I talked about more, design stuff. So let's actually get into some real building of things. So I want to create a calculator, VI, and that seems straightforward. No big deal. I'm going to have a little event loop here so I can catch my eventual application window close event as properly coding should result. I'm going to take two numbers, I'm going to add them together. No big deal. That sounds straightforward. But where did I start with this? And what we're saying here is actually you start with that. New application. You don't just start with a VI. You should always start with the application. We're actually going to provide a template that is just a new, nice, clean application with that event loop and all cleaned up and everything. We're also going to componentize some of our larger examples. So we're really pushing to, this is your starting point. This is your organizational tool. You don't just start with blank VIs, you start with a new application. So I do that, great. And I want to add functionality. So the first thing I do is I say, okay, great, I can just add, that's useless. I want to do more computations. So I'm going to throw a case structure around that with an enum that lets me pick the operation, maybe add a subtract operation in there. So this is now what my components look like. Over on the right, on the left, you can see I have my application component. I have add, subtract. I have this calculator cluster type def that gives me my operation, my two inputs, and my output. That all looks fine. But I realized, there's really no reason why my computational code needs to be in the same component as my UI business code, right? These could change differently. I could add ones to this. Or other people can just reuse this in a different application, right? They don't need to use my UI to use my math. So what if we actually go from this to this? We create a new library. We add and sub in there. And now we have this nice computation reusable library that's probably going to change at the same time. When I created that new library and I dragged add and sub in there, we automatically updated all the references. So your application still works, your green run arrow is still there. That's all great. But I said, having an enum as just an enum on the front panel, that's not good. That clearly needs to be a type def, so I'm pulled that into its own G type. And now I have these two G types. So just to kind of keep my code organized, I want to create a new namespace that actually allows me to, when I'm referencing the types, all my types are in one spot. And so yeah, it's like creating a folder called types, but this actually has meaning. Much like the components have meaning, namespaces have meaning. So when you reference this, you're referencing the fully qualified name of, my app types operator enum.g type. Yeah.
So are the namespaces also have to be reflected in on the folder?
The namespaces automatically get reflected in the folder hierarchy, and we also update all of that for you as you move things around. Yeah.
Okay.
And again, as I move my two types in there, it automatically updates the references, everything's pointing to the same thing. If you actually hover over, say, the use of those types, you'll actually see the fully qualified name on the diagram. Right? So that's great. I'm moving along, but actually, that case structure, my business logic, I want to capture that, because that's really kind of a middle layer, right? I have my UI stuff, I have my math down there, those are nice and independent, but that case structure is really the inner workings of my choice. Well, I don't need that to be stuck up with my UI. So let me pull that out, actually, and do its own component. So once again, I've created another component called picker logic. And I realized, well, actually, I need to have that enum down with that. So now there's a type in there. So I went ahead and created a new namespace in picker logic as well. And maybe I would actually just wanted to say like something, my company.types is my namespace. I could have even figured that out and had that namespace process components. I didn't actually do that in this example. So now I have 3 components that depend on each other. They actually go in increasing order of stability, right? My math ones don't depend on anything, so they're very stable. They just export their functionality. NXG has made me not export anything out of my application component, so that's extremely not stable. And then my middle one does both. So as I'm moving down, as I continually refactored my app, I've used those principles to actually have my component structure, well structured. Oh yeah, I was just saying with the type thing.
Out of curiosity,
Yes.
because you alluded to, you could have also have those enums in a common namespace, right? So could there be a namespace? Does it always have to be tied to the application of the component, or is that could it be separate from the root name?
Yeah, that's a good point. So the way I saying that now, like you actually have to. That would probably be a little trickier now that I think about it a little bit more. But each component or class has a root namespace that we don't show in this view, but it's actually there. And so you'd have to organize all of your namespaces. You basically have to almost combine names like components to have the same namespace to really pull that off, or pull just all those types out into a separate component whatsoever. So yeah, I may have misspoke on that one. That's a good catch. But we do let you change the root namespace of a component to be whatever you want it to be. It defaults to just being the name of the component. Yes. Yes, right. That's a good point. So what Jim was saying is that basically if I have just files that aren't in a component, which is a thing you can do, we're not being that draconian, they don't have namespaces. Namespaces solely live inside of classes and components. So if you want to just, get to my earlier point, sometimes you want to just have some loose PIs and just do something really fast. You don't have to understand namespaces and components and all that to do that. That's fine. Namespaces solely live inside of this structure of components and classes.
Well, you could, for instance, build a component that captures a whole bunch of types,
Mm-hmm.
and you can reuse that. In
Absolutely.
namespaces.
Yep. Yeah, and componentization is one of those things that's like everybody has an opinion on it, right? And there's lots of good opinions on it, right? There's lots of ways you can take a complex application and break it up. And so I think what the principles are saying, what I'm trying to say in this talk, is that as long as you're using the principles to guide that direction, and all of those, your choices kind of go along with those principles, you're going to end up with a good application design. And there's lots of different ways to pull that off.
So I'm maybe a little bit confused about what the benefit of the namespaces are, especially if your types, you pulled it into the gcomp, right? So it's a part of that namespace. And maybe confused with why you would make a specific namespace for the gtypes.
So this is a very simple example, so it seems a little ridiculous, right? But what I was trying to show is that the namespaces give you a way to have an organizational tool that the IDE understands that aren't necessarily just the components, that don't necessarily represent the distributable or unit or reuse. So the namespace is just it's really just a namespace. It's like just saying, hey, types. So I just want to have all my types in one spot inside this component. No one actually externally sees that, but it allows me to keep it organized and allows me to sort of have that extra level of organization and logical clumping of my code in a way that makes sense to me and the rest of my team.
So it might be equivalent to a virtual folder, or have some aspects of the virtual folder. I know that you guys kind of grow on top of it.
Yes, and so it's not a virtual folder in the sense of it's not dynamically detecting what's inside of it. Right? You're not putting a query on the namespace and saying all things that do X or Y show up here, right? Which is different than what a virtual folder is, right? So it's more of just saying, hey, like I said, a lot of people use namespacing for their company stuff. So basically the organization of the business is often shown in the namespacing, right? The way that they actually want the customer, if they have public APIs. If they want the customers to think about certain things in the public APIs that reference their company, they use namespacing for that. So it's really just a logical organization level on top of this physical reuse organization level that components provide.
Yeah. Is there anything preventing us from using the same namespace in multiple components?
No.
We can do
Yes.
That, my question would have been similar because we have now two namespaces called types. Are they, does the namespace use the component root namespace plus that
Yes.
namespace?
Yeah, so the name, right,
They're
so,
not the same namespace.
yes.
They are two separate namespaces.
Absolutely. So here, it's actually Packer logic, types, operator enum, and the other one is my app, types, calculator, UI. Yeah. You'd have to actually change the root namespace of the components to be the same. And then they actually will share the same namespace, which may or may not be a good idea based on your application and your needs. But,
Are there any scoping restrictions associated with namespaces?
yes, if things cannot have the same fully qualified name, we err out on that.
I guess I mean private. Can you make things private to a namespace?
No. Public-private is really only on classes.
Okay.
Components have a notion of export or non-export, which is kind of the same, but different. Right? It's a different tool. It's a similar concept, different tool. Okay, so let's actually get to building. So here's an animated GIF. Here's my app. I'm going to go build it. And you see at the bottom, we actually build the two libraries first because that's the dependency order. So I didn't have to name them 001 and 002 to get them to build in the right order. And you notice they also build GLL. So they build a binary, right? But my code is also in my project. So I'm not referencing some other project. It's all just there. And all just built in the right order. And if you actually have the complicated projects, you'll actually see a long list of your libraries get built first and get built in the right dependency tree. So that dependency tree I showed earlier, we build from bottom up. We do all that automatically. We know that dependency tree inherently, and we build things in the right order.
Are they coded separate on disk or are they coded into disk?
They're actually, the GLL is a separate file on disk. So if you actually look at the build output, there's a folder with the exe, there's a folder with the GLL, and there's a folder with the other GLL. So you actually end up with one folder that has 3 subfolders with each component's output in this folder.
And if you only change one of the libraries and do a rebuild, then you might just want to change.
Yes. So the initial release of this will not allow you to kind of update just the GLL, but that is obviously something that is important. And yes. Right. That is that soon after we will release it, we'll need you to patch the GLLs independently on your target.
So if you have two components with the same root namespace, you'll end up with one GLL or two GLLs?
You'll still end up with 2 GLLs, yeah. Because again, the namespace is like a logical layer on top of the physical layer, which is actually the component. It's a good time because I'm basically that. So,
But actually, on that question, what would the full structure look like if you change the same namespace or namespace?
I have not actually built. Do you know what that actually pops out?
You said the components define the full structure.
Yeah.
Too, so that's.
I don't want to tell you the wrong answer, so that's why I'm looking at Michael.
So when you build the actual GLLs, the top level folder that the GLL is going to give is going to be whatever the library component is called .gll. So you'll end up with 2 folders, not 2 GLLs, 2 folders that are named whatever the GLL is called. Which GLLs are inside of those folders.
Yes, that's a good way to put it. Yes, thank you. So the build output is purely, yes, that's I guess the same answer again, yeah. The build output is purely just based on the names of the components, and then basically what you see kind of during programming time is really where the namespace is coming in memory. Yes?
For multi-developer teams, if you build a component that you wanted to share with your industry, that you just get in source code, you get them and represent.
So you could do either way. Initially, you'll basically just be sharing these, but with just the source code, and that's what you can do right now, right? I mean, so right now, I can take that gcomp directory on disk, zip it up, give it to someone else, they can pull it into their project, it'll work. We do have basically kind of staged on our roadmap ways to sort of go in both directions, where you're distributing it just as a binary, or distributing a source and a binary, or just source, like whatever one sort of floats, your needs. But that is something we haven't quite gotten all the details yet out that we're currently working on and trying to figure out. But the idea is that you should be able to do, well, you should be able to most likely, there's going to have to be a binary somewhere because at the end of the day, something has to do the compilation. But you're going to be able to ship, basically, give someone just a GLL or give them source and a GLL, and there's pros and cons to either one of those options. And if you have questions on that, we can get much more detail with that offline. Okay, so in closing, yes?
Have GLLs cross versions of Lappy?
So initially, they will be tied to a version. We do, obviously, we know there's a need to allow a GLL to work in future versions of the runtime. So that is on our backlog. We will get to that eventually. But for the initial thing, yes, they unfortunately will have to be recompiled every time we release the RT or the runtime. But that's obviously a restriction that we know we need to eventually need to fix.
So in the short term, so currently the way that somebody might organize an application, like if my company has got a set of libraries, right? You might set those in one spot on the disk. As long as I've got my updating with my source control, like that's going to be what everybody else is using. As we transition to NXG, and people are starting to pull those in, and those files are getting sucked in all of the applications, and because the disk is here, I see the potential for those to get out of sync with each other. Or maybe I'm missing something about how they wouldn't get out of
right.
sync. If we're sharing source and not GLLs.
If you're sharing source, basically, let's say you have all your GCOMs as source on a network drive that we're all hitting. What's good if those are referenced in my, if I reference those in my project, every time I build whatever exe I'm working on, I'm going to rebuild all that source. And I mean, we cache it and do all kinds of magic, but basically, we are going to build a copy of that for that application and plump that down next to the application. And so as long as that source is staying up to date, every time I rebuild, now if you update the source and I don't have to rebuild my app, yeah, my GLL obviously is not the most up-to-date thing, right? Well, that's not right. Yeah, that is right. Yeah, obviously, if we're not going to, once we make an app, it all just sits there with whatever version of the source, compiled version of the source that was there when we built the app. Eventually, you want sort of, those things to be add-ons, right, in some sort of shared location. And as you push out updates, we'll automatically pull those updates in, and there will just be a new GLL sitting there that we depend on. And so that's how we want to go in the future, where we can actually depend on GLLs, and you can independently update those GLLs, and that way push out updates just for each library, not for the whole app as a whole. But right now, you have to build the app sort of monolithically every time you want to build it.
In that scenario, would there be a versioning information for all GLLs you're using?
Yes, I mean, at that point, right now, all the GLLs have to be tied to the same version of the runtime. Like I said, we want to eventually allow for GLLs that are compiled to be run in future runtimes. That is not what is going to release in the next version.
No, I mean, as developers create new versions of GLL and bring it in, will that version, not to the library version, but the version itself, like 1.2.1.0, 1.2,
right.
Will that be reported?
So the current plan, as long as that does not break the kind of interface defined by the GLL that the initial application was built under, we will use it. And so basically we will check it and we will basically report to you, oh, hey, this type has changed. We can't deal with this. You may want to go rebuild the consumer of that GLL, right? That you rebuild your app. But we're not putting any numeric version checking in that breaking changes check. We're just looking for things that we can adapt to in terms of types, campaigns, things like that.
What I'm looking for is if I'm going to validate a higher level application with multiple GLLs, that those can be listed out in my validation.
Yep, that's interesting. And so if you're trying to do that by a specific version number, that's an interesting requirement. So I think I'd like to talk to you about more detail about kind of what you need there.
And along the same lines, I mean, is there a way to actually version the component itself in a way, or will it auto increment?
Yes. So I didn't show that, but there is an auto increment version
As you build.
on your
Always-
built in.
always-
Yep, they'll all do that. You can turn that on and off. You know, where you
That
are.
could create interesting problems if you share the same source, standard bound version, and then some people build competing GLLs at the same time that have the same version number
Mhm.
because they started at the same base. But that's, I mean, maybe not a very common scenario. I'm more interested in, like, I'm distributing this piece of code that we agreed upon, and that's why the versioning becomes very important.
Right.
Because if it needs to live with a specific project, a specific version, because that's tested and released, right? That's why it's
Yeah. And you can always take the specific built GLL and like continue to use that and not make sure it's not up, like on a deployed system. You can choose not to upgrade that GLL because you know that thing works, right? And you can there's policies that you do to basically make sure that never gets updated. But you're right. There's some interesting things we need to work out. I think, and like I said, we haven't been thinking about using like numeric versions as sort of breaking change rules. We've been looking for kind of more like code-based things, like, oh, you know, you change this type or you change your content or something like that. Using like actually more of a policy sort of thing says, I only want this app to work if it's version 1.3.5 or between 1.3.5 and 1.4 or whatever, right? That we haven't thought about much, and so that's a really interesting use case that I'd like to get more into. Let me go back and find you. Yeah.
So distribution-wise, I would think that if you want to go the plugin route and have a whole bunch of reusable components,
Yep.
and be able to use different versions for different types of applications, say across your company, what is kind of the best practices there? Is it project essentially defines a virtual link to that? And then system, or maybe system link or package manager simply pulls that in automatically via version, or what's
So,
the vision there?
we have built these very much to like kind of work very nicely with package manager. And so there's a way even just from within the NXG that you can create a package that distributes your exe. Eventually we'll allow you to do that so it distributes your library you know, in compiled form. We haven't got there yet. But we do sort of expect the package dependencies to kind of, and that's where you can actually get into some of the versioning, right? Where the package dependencies actually say, oh, I need version X to work. And so the dependency tree sort of your application and all your libraries that'll actually be managed by package manager. And so if you build individual packages of all those different GLLs, package manager will go and make sure you have all the right versions and install those correctly when you install your application.
I don't really see, you know, using subrepos or submodules like Git or Mercurial
Right.
to manage that, because they are binary
Yeah.
things, although they're fairly small, but
Yeah.
still.
And there's some advantages to using a GLL only, just releasing only GLLs. There's also some disadvantages in the sense that like source can adapt to changes dependencies below it. So if you have shared dependencies between two GLLs, if you also have the source, you can adapt to some of those changes in those shared dependencies a little bit easier. But there's also advantages on GLLs where no one sees the code, right? It's opaque, and so we're trying to catalog those disadvantages and advantages of the different approaches and make sure that we are very clear to you all when we release these things when to use one versus the other and what the pros and cons are.
It's kind of perhaps an odd question, but security. Is there anything preventing me, if I have access to a computer, from building a separate GLL that has the same interface but has completely different functionality and replacing the one on disk and having the application running?
No. So if the interface basically is still the same, we're going to allow it. We're trying to be pretty, like, what's the word I'm looking for? We want the app to run as much as possible, right? And so we want it to be adaptable to as many changes as possible. So as we start to build in these rules, we're trying to make them pretty sophisticated. But no, I mean, if you maliciously update your GLL, once we sort of get to that point. Right now, if you update the GLL, we're just going to be like, sorry, we're not running your app, your GLL is different. When we get to the point where we actually allow you to update GLLs, we will be mainly looking more at sort of, like I said, the programming aspects of it. Again, like the versioning thing that you brought up, I think that's an interesting thing to think about of like some sort of signature or some sort of signing thing, key signing, whatever. So more from a security perspective of saying, hey, don't load that GLL and like that thing is like signed properly. That's a really, and because I mean, Windows does that kind of thing. So I think that's really interesting to think about further down the line as well. So that's good feedback.
Query the kind of function called
So we do expect there to be some way to kind of query metadata from a plugin component. So if you have a GLL on disk, you should be able to there should be an API where you basically can get information about that before you actually go through the process of fully loading it. Like I said, that part we haven't got to quite yet, so we're still tinkering on the design. But we do obviously need some sort of metadata ability to kind of read that beforehand. Absolutely. It's a good question. Okay, I'll start.
Is there any capability or the plans for something to visualize these structures?
Yes. So we do have the call hierarchy view and the class hierarchy view right now. The goal is to eventually, and this will be a little bit further out, unfortunately, but the goal is to eventually see that component dependencies as well, either as an overlay or its own thing, or we're not quite sure, but something, we absolutely want to visualize that. Because we were just laughing when we were going through a practice version of this talk. It's like, oh, it'd be really nice to show that, right? Because especially when you sort of think about those principles become very evident when you look at the dependency graph, right? And you could do things like, if you had a cycle, we could then pull it up and say, look, here's a cycle, go clip that cycle. We could do all kinds of helper stuff like that. So yes, we want to do that. That's a little bit more ways out, but that is definitely something we want to push on, because just the increase in understanding of your architecture would be a sort of exponential jump once we have that. Okay, last call. Okay, I'm going. In closing, components are good. Go read Clean Architecture. It can be a little dry at times. Maybe read it in pieces, but it's a good book. It really spells out not only the solid principles for class design, but also these component principles for more application design and a bunch of other stuff. It's a great book. LiveUnix uses applications and libraries. Those are our main two organizational techniques. We encourage everyone to use that for any application of scale. And please reach out to me with feedback. I'm going to be around all week. I made the Lava thing tonight. I have an email address. That's my first and last name at first.last@ni.com. Please reach out to me. I'm on the forums. If you have feedback about this, if you have requests about this, if you have things you want to know about it, please reach out to me. We want to hear about it. We had some great conversation here today. I expect there to be more and more things like that, and I want to know about them so we can actually get them on the roadmap and get them in the product. So, with that, thanks everybody. Have a good week. Oh yeah, take the survey and stuff like that. So, thank you.